Welcome to classes on physics. Today's class is on ray optics, and it is the chapter from higher secondary second year. And this is a very important and interesting chapter. And you please minutely follow the lecture because this lecture is based on the concept which will cover not only your exam point of view, board exam point of view, it will cover all the entrance exam. So the chapter is very beautifully systematically arranged, and please try to follow the class minutely. So let me first tell something about the things you have only a knowledge about, and these things I am giving you a brushing up the facts in a very swift manner. This is the concept you have only come across with this in class first year, or probably in the metric also you have got the concept. So a bit different way I will just explain what is real image and what is virtual image. Many of you know when the reflected rays or refracted rays meet at a point, actually meet at a point, and that point in which they meet, reflected or reflected rays meet, that gives you a real image. Again, when the reflected or refracted rays appears to meet at a certain point, that gives rise to an image which is termed as virtual image. More often you can understand the fact when I will draw. Very simple. I have taken the two examples. One is plane mirror, and very often maximum of you know that when the image formed by the plane mirror is a virtual one. So I have taken an object here, and from this object I have taken two rays incident upon the plane mirror, and they reflected in this way, incident and reflected, incident and reflected. And this reflected, if it passes in this way, there is no chances of to meet at certain point, so there is no question of actual meeting. So we extended the reflected rays in the backward directions and meet at a certain point, and this is called virtual image. When reflected rays meet at actually at a certain point is called real image, and if appears to meet at a point is called virtual image. So it appears to meet at a point is called virtual image. If you take a concave mirror, later we'll tell details about this mirror. So if you assume two parallel rays, then this parallel ray will pass through the focus, and this is the point where the image will form, and this image is the actual meeting point, and this is a real image. So this is a real image. This is very simple thing, nothing to explain, maximum of you know. So for your brushing up of the knowledge, just I am mentioning the facts. Laws of reflection. I think I did not to explain in details, and you know it. If it is a plane mirror, and if you draw the figure like this, if you inclined incident ray falls in this way and it meet at a certain point, and where we draw a normal, say OA, and it will reflect in this way where angle I and angle R will appear. Angle I is called angle of incidence, angle R is called angle of deflection. The first is angle of incident equal to angle of reflection, nothing more. Number two, the angle of incidence and angle of the ray of incident ray or the reflected ray, incident ray, reflected ray, and the normal at the point of incidence will remain at the same point. This is very simple. Again, it is known to you all. The angle of incident, angle of reflection is remain the same, and the incident ray, the reflected ray, and the normal drawn at the point of incident will remain in the same plane or same point. And third one is the velocity of light, frequency and lambda wavelength will remain the same as that of incident ray. Am I right? But the intensity of the incident ray after reflection will decrease and other things will remain same. This is all about the laws of reflection. So reflection from plane mirror, we will just here add up a very two important points which you have not probably have not got this point. Deviation of angle. So here is very simple thing, there is a deviation, and if it is a plane mirror and if the rays are incident in this way, the incident ray will reflected in this way, we will get I is equal to R, where I is equal to I also because I and R are equal. So if you want to calculate the angle of deviation, that this deviation is that delta, and that delta is found to be 180 minus twice I. 180 minus twice I. This is total 180, and I and R means I and I. 180 minus twice I will give you the angle of deviation. Inclined at certain angle, say theta. Let us see what will be its angular deviation when two plane mirrors are inclined at certain angle. Say this is one mirror and this is another mirror. They have inclined at an angle theta. Say one ray of light fall upon this one. So if the two mirrors, plane mirrors, are inclined at certain angle theta, and if ray of light is fall upon the first mirror, say one, it will get reflected, and this reflected ray again will fall upon the second mirror, and it will be reflected in this way. So the total deviation of angle delta is equal to 360 degree minus theta. So now let us see, many of you also know this fact, but a bit I will add up something more. Images by number of images by two mirrors inclined at angle theta. Let us see if the two mirrors are inclined at an angle, as earlier I have shown you, an object is placed in this way, and say it is theta. Am I right? What are the possibilities of finding producing number of images by these two mirrors which are inclined at angle theta? So many of you know that number of image is equal to 360 divided by theta minus 1. But here I will add up something where number 1, where 360 degree divided by theta is an even integer. Means if you divide by theta is equal to, you will get the number of image is equal to 360 divided by theta minus the value of theta is odd. You assume the odd value and find the theta, say 180, and you will find two things. That number of image will be 360 minus theta minus 1 if The object is placed symmetrically. Object is placed symmetrically because these two angles are equal. If you place it symmetrically, so if it is placed symmetrically, here object is placed symmetrically. It is when from the object, if you draw a line and if these two line makes two angles, these two angles are same, then the number of images will be 360 degree minus theta minus 1. Now number of images will be 360 degree by only theta, not minus 1, if the object is placed asymmetric position, not in the middle, not in exact bisector point. In this position, if you place, then the number of images will be 360 divided by theta. Another thing, moment of object and image. Number one case, if mirror is fixed and object is moved. Say this is a mirror, we have placed an object here. Now if you move, mirror is fixed, if you move towards the mirror or away from the mirror, so the speed or velocity of the image will be at the same of the movement of object towards or away. So it will have the same value of the movement of object towards the plane mirror or away from mirror. Now if the case number 2, mirror is moved, object is fixed, then the speed of formation of the image will be twice of movement of the speed of object towards the mirror or away from the mirror. The moment of the image will be twice the speed of the movement of object Now let us find out the height or length of the image for which a person can view his image full in front of the image. What size of the or length of mirror is required for an object or for a person to view his object incomplete. Say this is a plane mirror. We have used a plane mirror of say height h and say how much, what is the length of this height of this mirror to view the complete picture or the image of the object. So if you draw the diagram, you will find that if the mirror is h by 2, the object is h, means to complete view of an object, the length of the mirror should be half of the length of or height of the object. So now let us see what will be the height of the mirror, for a person or for a object to view his image in full complete, so also his background wall is also to be viewed incomplete. So for this condition, let us assume a mirror like this. In this condition, you need say it is wall, back side of the object, and say its height is h. That height and the object should be viewed clearly incomplete. So we should, here a condition, we should place the object in between wall and mirror. So in this case, to view the object and the wall, when object is placed between the wall and mirror, the height of the mirror should be 1/3 of the height of the wall, provided the object should be placed exactly in between wall and mirror. So one of the very important things very often you will come across is the sign convention, and this sign convention is very important in order to calculate the value of object, image and focal length or magnification some things. So first of all, you should know the sign convention, what sign is to be given to object, image and focus for a mirror. So this is for spherical mirror, and sign convention very simple things. uh, when mirror is placed in this position, and if the object is placed towards left, that is from the directions where light is coming, that direction, if you place the object here, that is from that direction light will fall upon the mirror. So from left side where the object is kept, here u is minus, u is minus, f is minus, and if the image is formed above the axis erect, it is plus, and if it is inverted, it is minus. So now let us assume real image, and we will show the diagram how to get the real image and how to get the virtual image, and also you have learnt it in class 10 also for concave mirror and convex mirror and lens, also a bit idea you have got a bit idea. So So if you assume the concave mirror, say this is concave mirror and center of curvature, and this is focus. Say if you assume, I am showing you a very simple ray diagram. So you see, according to sign convention, if it is a concave mirror, the condition is this for object, image, focus, object height, image height, radius of curvature, magnification. For object V, U, V, F, all are at the left of the mirror. So object U is equal to minus V means image is also towards left, it is minus, focal length is towards left, minus object height, since it is in above, it is plus, the radius of curvature again it is minus, and magnification is equal to minus, because magnification is a bit later we will get V minus U, and hence it is minus. So if these images are real, then object must be placed at a distance which is smaller than at a distance. I think it will be this should be greater than equal to, and this should be less than equal to, because if the object distance is greater than focal length, at any distance greater than focal length or exactly equal to focal length greater than equal, then all the images form will be real. And if the image is placed in between pole and center of curvature focus, that is at a distance less than focal length, that is in between this length, then all the images will be, for concave mirror, will be virtual, that is object is at a distance less than focus. So I have shown you that all these things will be minus, 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 plus, minus, 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 and for virtual that will be depending upon the formation of the image is always in the other side. If it is virtual, so it is plus, object is always left side. It is minus, object is towards right. It is plus, focal length is always towards left. It is minus, object is again in virtual case, it is dot 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 in the straight plus. So likewise you judge yourself, you see it is in this sequence. But if the lens is minus, convex lens, so if the lens is the convex means in this way you are placing the light in these directions, so except object all other things will be positive. So keep it in your mind, it is a very simple thing. Except object, it is always towards the left, and others all things will be positive. So this is simple sign convention of U, V, F, O, I, R, M for concave and convex lens, and condition for real image and virtual image for concave lens. Concave mirror, I am not showing you much because maximum of you know, and convex mirror. In one diagram I will show you. So here this is concave mirror and this is convex mirror. Here the light is falling on the curved surface, here light is falling on the outside of the curved surface, and other side is colored. Light cannot pass. So when a parallel light pass upon this one, it follows through or passed through or reflected through the focus. Am I right? So for concave mirror, and for convex mirror, if the parallel rays pass on the mirror, then it will appears to divert from the focus of the mirror. So this is C1 is the center of curvature from the sphere or the bulb. It is circle, and this is called center of curvature, and this whole length is called radius of curvature, and half of radius of curvature is focal length. It is known to you. The same way it is also like this. So this is concave mirror and this is convex mirror, and this is principal axis, this is principal axis. So in it we have got center of curvature, radius of curvature, and half of radius of curvature is the focal length for both concave mirror and convex mirror. You have already done in class 10. That's why I'm not spending much time upon this. The mirror formula of the spherical mirror is 1 by f is equal to 1 by b plus 1 by u, where b equal to image distance, u is equal to object distance, f equal to focal length, and if we know r is equal to twice f, or f is equal to r by 2, because focal length is the half of the radius of curvature. So it should also be known to you. And from the mirror formula, another important thing is that magnification is equal to minus v by u. Magnification is minus v by u, and that is equal to and this part is very important, and very often you will come across in solving out the problem. Who will solve out the problem, you will find this is very important. But in metric level higher secondary class 10, you have got up to this one, and I have given this is that magnification can also be written as f minus v by f or equal to f by f minus u. If question is in terms of image distance, then you use this formula, and if the question is in terms of object distance, you use this formula, and m is equal to f minus v by f or f by f minus u. So you may think where from these things come. So in a very short way I am showing you 1 by So I am showing you one part, very simple, where from we get these two terms, magnification equal to this. So very simple, we know 1 by b plus 1 by u is equal to 1 by f. Multiplying both sides by ub, we will get u plus b equal to ub by f. Now let us find out b. If you find out b, we will get one this one. If you find out u, we will get one other one. We will get other one. So if you take out u this side and you take LCM, you will get u v minus fu by f, and take common u is equal to v minus f by f, and then in the last step v by u is equal to v minus f by this. But in magnification, what is magnification? There is a minus sign. So if you make a minus sign, it will be f minus b by f, f minus b by f. So we have got V by minus V by U is equal to F minus B by F. Am I right? Likewise, if you take V out this side and U this side, you will get this one. So this is very important. You please try to keep it in your mind. M is equal to minus B by U is equal to F minus B by F, or 1 by F minus U in terms of B and in terms of U magnification. Very important. Refraction. Again, no need to tell the definition. In case of reflection, the incident ray and the reflected ray will be in the same media. But in case of refraction, you have got in earlier classes, there should be change in media. Light will change from one media to another. This is called refraction. And you know the matter or the phenomenon of refraction. If say it is air media and say it is water media or rarer or denser media. So this is called angle of incidence and this is called angle of reflection. I am not writing anything. So here you see angle of incidence, and upon which we have drawn, on this point we have drawn a perpendicular from air medium to water, and light is made to fall from the lighter medium or rarer medium to the denser medium, and we have seen that the refracted ray is bent towards the normal, and the case will be the reverse if the light is made to fall from denser to rarer medium. If it is denser and if it is rarer medium, and if you want to make refraction and from denser to rarer medium, we will see the ray will bend away from the normal. So in first case, when light is made to fall from rarer to the denser medium, the refracted ray bends towards the normal, and if from denser to rarer, the case is the refracted ray will bends away from the normal. This is very simple thing, but here for the refraction we will just define Snell's law. So it is called Snell's law. Whenever you have already seen the angle of incidence and angle of refraction in case of refraction from rarer to denser or denser to rarer, if you take the trigonometry sine of angle of I and sine of angle of refraction, that is R, you will find the value of this is always constant, and that constant is called mu, and that mu is called refractive index. Am I right? So if it is sine 45 and if it is sine 44, you calculate this value, will get a one value for one media. If it is air to water, if you go on changing the angle of incidence and angle of refraction, you will get the same value of mu, refractive index, for that media. And if you change the media, again you will get different value of mu of refraction, but you change on angle of incidence from that, say from air to glass, again you will get the mu a fixed value upon changing angle of I and angle of R. That is what is explained by Snell's, and hence sin A by sin R is equal to mu is called Snell's law. Media 1 and media 2 we can write now. Also for media 1 to media 2, if you just made to fall the light from media 1 to media 2, then we can write that that mu 1 to 2 is equal to mu 2 by mu 1 is equal to sin A by sin R. Again, if you cross multiply, mu sin I is equal to mu 2 sin R, that is mu sin I and sin A by sin R equal to constant, that is mu sin of any theta is equal to a constant term. This is a bit extension of the law. So extra information on refractive index. Refractive index so here you can tell something more about the refractive index. What does actually mean? It actually means, and it is that characteristics. It is the characteristics of the media which decide the speeds of light in that media. So refractive index also indicates about or decides about the speed of the light in that media, and it is unitless, dimensionless, and it is a scalar quantity. Refractive index, and other is relative refractive index. Now what is absolute refractive index? It is when the light passes from vacuum to any media, vacuum to water, vacuum to glass, vacuum to oil, vacuum to diesel, vacuum to petrol, terpene, anything. When it comes from the vacuum and falls upon another medium, then refractive index of that media with respect of vacuum is called absolute refractive index. Means refractive index of a medium in terms of air or vacuum is called absolute refractive index. Means mu A to glass is 1.5 or 3 by 2, or refractive index of water is equal to 1.33 or 4 by 3, or refractive index of diamond is equal to AD 2.4 or 12 by 5. So whenever you are told that refractive index, it means absolute refractive index. Refractive index of glass means it is absolute with respect of air. Refractive water with respect of air. Refractive index of diamond with respect of air. Here relative refractive index is here. You will never get the term vacuum, because it is not related to the vacuum of or air. It is related to the fixed media, from water media to glass media, for glass media to water media, so any other two media. So when when light passes from medium 1 to another medium 2, then refractive index of medium 2 with respect to medium 1 is called relative refractive index. So that relative refractive index mu 1 to medium 2 is equal to medium 2, refractive index 2 by refractive index 1, or mu 1 to may also be written as 1 by mu 2 1. Just you keep it in your mind, nothing complicated. Though this relation is not required to learn by heart, just to keep it in your mind, because there is a relation between refractive index of and lambda, that is wavelength of light, which was proposed by Cauchy, and this Cauchy's equation is equal to mu is equal to that Cauchy gave the equation, the refractive index and the lambda of the wavelength. Lambda is equal to A plus B by lambda square plus C by lambda square 4 plus dot dot dot, where A, B, C are constant. Now from this we just can relate is refractive index is nothing but related to 1 by lambda. So more the wavelength of light, less is the refractive index, and less is the refractive index, more is the wavelength, and vice versa. So from here we can say the wavelength of red light is greater than wavelength of violet light, or in terms of refractive index, so it will be the reverse of this, as mu is inversely proportional to this. Again we can write refractive index 1 2 is equal to refractive index mu 2 by mu 1, and that is equal to, in terms of lambda, since it is related to inversely proportional this, so this will be lambda 1, this will be lambda 2, and in terms of velocity, in velocity is directly proportional to lambda, so v1 by v2. Again this is a very important correlation, from where you can do a lot of questions answer, where the mu, refractive index, lambda, wavelength of light, and velocity of light of different color is correlated. So with the help of which you can use that formula can be used in solving out a lot of questions answer in entrance, also in the board exam. That is mu refractive index upon some factors refractive index depends. Now what are these terms upon which refractive index depends? Number one, so in short we can tell that of factors upon which the refractive index depends, it depends upon the nature of the media upon which the light is refracted. Means if it is glass media, if it is water media, if it other media, upon the nature of the media upon which light is refracted, the refractive index depends. And it also depends upon the color of a substance or the color wavelength of the light used. We have already seen that lambda is inversely proportional to mu, or mu is inversely proportional to lambda. And refractive index also depend upon the temperature. If temperature increases, refractive index will decrease because it is inversely related. This is a very important point which I am going to discuss. Let us now explain the real and apparent depth of a substance. Here the observer is in the rarer media, he is trying to view some substance, the substance or object is in the denser media. So let us see what's happened. We are now consider the case when the observer is in the rarer media and the object is say in water, inside the water at depth h below the surface of the water. Say this is the object, and when the light comes to the eyes of the viewers, now it burns away from this one, and if you extend this light in the backward direction, we'll see that object is to be viewed in this position and it is shifted a bit. So we know mu is equal to real distance, where real depth is by greater than apparent depth, is h by h dash. So h by h dash equal to mu. Now the d is the shift. Now what is that shift? It is very important you please try to understand this. Then the shift is equal to h minus h dash. So h minus h dash will give you the shift. How much shift from the original depth to the apparent depth? What is the amount of shift occurs when observer is at the rarer medium to view the object in the denser medium? So let us now find out the relation h. What is h dash? From here you can write h dash equal to h by mu. So you can put it h by mu. So that is h is equal to 1 minus 1 by mu. So we get d is equal to h into 1 minus mu. So for glass, in a glass slab of huge thickness, an object is placed below the glass, and if an observer wants to view this substance in the glass slab through the glass slabs from rarer media. Now let's see what is the amount of the shift occurs of this substance. Now we know d is equal to h by 1 minus, for glass it is 3 by 2. So 3 by 2, 1 by 3 by 2 is equal to 2 by 3. This is equal to h by 3. So now for water, what's happened? Water refractive index is equal to 4 by 3. Now if you put this value 4 by 3 means 3 by 4 means H by 4. So for shift of substance to be in water, the shift D will be H by 4. In case of glass, equal to D is equal to H by 3. It is very important formula because sometimes you may be given the shift, or may be given mu, or may be given this. Any three of may be asked to find out. If you know the formula, you can very easily find from the case 1. Now observer in denser medium, object is in rarer medium. Now let us see the shift. Here you see, if it is denser medium, the observer try to view some substance in the denser medium. So the light from the substance come upon the eyes, come on the eyes of the observer. In this way, it's when it passes from rarer to denser medium, bends towards the normal, and in this way if you extend this one, thus object will be viewed in this direction. The shift will be this much. D is the shift, and original apparent length, here apparent length is, here apparent height is greater, other case it was smaller than real depth or height. Again we know that mu is equal to f, real length, always real length by this. So mu h dashed is equal to mu h. So here D is equal to what? D is equal to h minus h dashed h. Here h dash equal to mu into h. So h into 1 by mu is equal to D. So for different media, you place the value of mu as I have done earlier, and you find out the shift in the height or depth. So I'm not going to write the definition, just I am telling. The first thing is that when light passes from denser to rarer medium, the reflected ray burns away from the normal. It is known to you all. It doesn't go in this direction, it burns away from the normal. So as you increase the angle of incidence, and consequently we will get, if you increase the angle of incidence like this, so we will see the angle of refraction will also increase. So a time will come when for certain angle of incidence in the denser medium, when light passes from denser to the rarer medium, at certain increase of angle C, the angle of refraction is 90 degree, and that angle is called critical angle. Again, if you further increase the angle greater than critical angle, so the light does not passes to the another media, it comes back to the same media, and hence it is called total internal reflection. Why it is called total internal reflection? Only because of the fact that total, why the word total is called, why it is not called reflection. It is total internal reflection means at the times up to critical angle or smaller than angle, we see some of the light passes, not all, passes to the rarer media with increase of the angle, means angle of reflection deviates, angle of ray of light, reflected light deviates, bends away from the normal, means the light which you used to pass from denser to lighter medium, so there are some chances of the light passes to the rarer medium till there are some light which are already in the interior of this, remains inside of this denser media, and in this way not all the light goes to the rarer media, but as soon as your angle of incidence is greater than critical angle, then not a single ray of light passes in the rarer media, all light pass to the come back to the same media, hence it is called total internal reflection. In other cases, if it is less than or equal to critical angle, then some of the light passes to the rarer media and some of the light internally remains inside the denser media, but as soon as the angle of incidence is more than the angle of deflection, all the lights without any chances of the passing to the rear media, all the lights come back to the same media, hence it is called total internal reflection, and it is very important phenomena. The concept or principle is utilized in various form where 100% reflection is not possible. In case of glass also, if it is a glass slab, if you pass through the light, some light will reflect and some will pass through it. So it is the very excellent way in which internal reflection, all 100% of the light is made to pass in the same media without any loss of light or chances of the light to pass in the rarer media, hence it is called total internal reflection. If I show you diagrammatically, you can very easily understand total internal reflection. See, very simple way, I have just diagrammatically explained the phenomenon of total internal reflections. You see, when light is made to pass from denser to the rarer media, from this point, if light is inclined upon the interface of these two media, light deviates from this one, this is angle of incidence, this is angle of reflection. Now, if I made the angle a bit more than this angle, then there is a chance of that light passes through the interface of the two media, making the angle 90. So the angle of incidence for which the angle of refraction is 90 is called critical angle, and I have designated by C. Now again I have made to pass this light with greater than this angle, critical angle, greater than this angle, then you have seen that light, instead of passing through the media, other media, or passing through the separation of two media, it has exactly in 100% come back to the returns to the same media, and that angle which is greater than critical angle for which the total internal reflection occurs, this phenomenon is called total internal reflection. Now what are the phenomenon can be explained by total internal reflection? Number one, looming. It is seen in cold region. Other one, mirage. It is seen in desert. Optical fiber, it is a very huge modern technology where optical fiber use the total internal reflection, where there is no loss of incident light. The light which is incident here can be shown in America or in other long distance place in exact intensity, because there is no long loss of time. Hence total internal reflection is a very good principle used in optical fiber and explaining looming in cold region, cold area, and mirage in desert, and brilliance of diamond because of repeated total internal reflection. Repeated total internal reflection, there is sparkle in the diameter, because in the angle of this, because the angle in diamond is 24 less the angle, more is the reflection, more is the angle reflection. I am just deriving the relation. If mu is equal to 1 by sin c, we can relate it is where c is the critical angle, lambda is inversely proportional to 1 by mu, and 1 by mu is proportional to sine of critical angle. Again we can tell this one. So sine of c is equal to 1 of mu rarer to denser is equal to mu denser to mu rarer is equal to mu is related to lambda rarer to lambda denser, and this is related to the velocity is directly related. So we can relate critical angle with refractive index rarer to denser, denser to rarer by formula I have already mentioned, and mu is inversely proportional to lambda, so this will above, this will below, and directly proportional to the velocity Vr by Vd. So this is very important correlations of critical angle mu, lambda and v. Critical angle mu, lambda, velocity relation. Very important, and very often you will find it application in solving out the problem. Refractive index inversely proportional to critical angle. Say smaller critical angle, these are critical angle, the repeated refractive in the total internal reflection is more in the diamond, and diamond, this is mu, sparkles. This is all about of today's class. Hope you have followed the class with utmost patience. In the next class I will start with lens. So thanks for a lot for watching the class.